2018 Leaving Cert Higher Level Question 2, Paper 1. You're told that the first three terms of a geometric series are x squared, 5x minus 8, and x plus 8. Use the common ratio to show that x cubed minus 7x squared plus 80x minus 64 is equal to 0. Now it's kind of a clue. We'd have to multiply something x squared by x to get x cubed, and they tell us the common ratio. So we know that in a geometric series, the first term a is equal to 2 and the ratio is equal to 3. We multiply 2 by 3 to get the second term, which will be 6, and the third term will be 18. So what can we say about the relationship between these numbers? Term 3, 18, over term 2, 6, is equal to term 2 over term 1. So that's what we have to show here. Term 3 over term 2 is equal to term 2 over term 1. And you can see that's where we're going to get the x cubed with the x squared by the x plus 8. So x squared by x plus 8 is x cubed plus 8x squared. And that's equal to 5x minus 8 to be squared, which is 25x squared, minus 40x twice, which is minus 80x, plus 64. So we bring all these terms to the left. We're going to get x cubed plus 8x squared minus 25x squared plus 80x minus 64 equals 0. And you can see that it's going to match off with this. We're going to get x cubed minus 17x squared plus 8x plus 80x, left out the 0 up here, plus 80x minus 64 is equal to 0. In part 2, you're told that if f of x is equal to this guy, show that f of 1 is equal to 0 and find another solution. So this is our box method division of a cubic. F of 1 is 1 minus 17 plus 80 minus 64, which is going to give me 81 minus 81, which is equal to 0. Now if 1 gives me 0, we can say that x equals 1 is a root. So x minus 1 is the factor. So if we divide x minus 1 using our very simple box method into the cubic, we'll get a quadratic that will give me the other solutions, or the other solution. So the first term of the cubic in the first box, and the last term in the last box, and my factor on the outside. And then we divide in. These two boxes give me x squared, these two boxes will give me x. So we say x cubed divided by x is x squared. X squared by minus 1 is minus x squared, and then we jump back up. We say, well, we want 17 or minus 17, so we're missing minus 16 of them. X into minus 16x squared is minus 16x. Down the bottom, minus 16x by minus 1 is plus 16x. We're looking for 80 of them, so 64 of them are missing. And x into 64x is plus 64. And as we can check our answer, if this number by this number is this number, which it is, we know that we've done it fully correct. And you can see here there is just one more solution. If we solve this, we're going to get x minus 8 squared is equal to 0. So x is equal to 8. Part C of this question asks, in the case of one of the values of x from part B, the terms in part A will generate a geometric series with a finite sum to infinity. Find this value of x and hence find the sum to infinity. Now we know that if there's a limit to what the geometric series will add up to, that's when we call it a sum to infinity. So we've seen this with the fly jumping across the table halfway each time. So we need to have some piece of information from the terms above. Let's see what they were. So these were my terms, x squared, 5x minus 8, and x plus 8. So we put the two values in, we'll see what we get. We get 1, for x equal to 1, we get 1 minus 3, 9. So this has a common ratio of minus 3. For a sum to infinity, or the ratio has to be greater than 1. So let's put 8 in. We're going to get 64. We're going to get 5 8s are 40 minus 8 is 32. And we're going to get 8 plus 8, which is 16. So you can see or is equal to a half here. We're asked to find the sum to infinity. So this is where there will be a limit to what the sum can add up to, and that's what we're asked to find. A is equal to 64, R is equal to a half, and the formula is given to you in the formula booklet. It's S to infinity is A, that's an A, over 1 minus R, which is 64 over 1 minus a half, and 64 divided by a half is 128.